Alright students, I am going to do some numericals today. The number density of free electrons in a copper conductor is estimated as 8.5 into 10 to the power 28 per meter cube. How long does an electron take to drift from one end of wire 3 meter long to its other end? The area of cross section of the wire is 2 into 10 to the power minus 6 meters square and it carries a current of 3 ampere. So Vt stands for drift velocity, I stands for current. Obviously current is expressed in ampere. N stands for number of electrons per unit volume. Number of electrons per unit volume means density of free electrons, which is given 8.5 into 10 to the power 28. E stands for charge of electron. A stands for area of cross section. So drift velocity I is given how much? 3 ampere. Number of electrons per unit volume means electron density 8.5 into 10 to the power 28. Charge of electron 1.6 into 10 to the power minus 19. What is the area of cross section? 2 into 10 to the power minus 6. So this is the drift velocity. Vd stands for drift velocity. 3 by 8.5 into 10 to the power 28 into 1.6 into 10 to the power minus 19. 2 into 10 to the power minus 6. This is area of cross section, this is charge of electron, and this is electron density. We are going to find out the time. So time equal to distance by speed. So 8.5 into 10 to the power 28 into 1.6 into 10 to the power minus 19 into 2 into 10 to the power minus 6 divided by will give you 2.72 into 10 to the power 4 second. Answer. A current of 1 ampere flows through a wire of cross section 1 millimeter square. Assuming the free electron density within the wire to be 8 into 10 to the power 28 per meter cube, calculate the average drift speed of free electrons. I stands for current, N stands for electron density, that means number of electrons per unit volume, E stands for charge of the electron, A stands for area of cross section. So what is the current given? The current is given 1 ampere divided by what is the electron density? It is 8 into 10 to the power 28. Charge of the electron 1.6 into 10 to the power minus 19, and 1 millimeter square area of cross section means 1 into 10 to the power minus 6. It will give you answer. The resistance of two resistors connected in series is 20 ohm and 4.8 ohm when connected in parallel. Find the values of resistances. Let the values of resistances be R1 and R2. So according to the problem, R1 plus R2 equal to 20. 1 by R1 plus 1 by R2 equal to 1 by 4.8. Okay? Or R1, R2, R1 plus R2 equal to 1 by 4.8, or R1 plus R2 is how much? 20. So 20 by R1 R2 equal to 4.8. Please copy this down. R1 plus R2 equal to 20 connected in series, and in parallel 1 by R1 plus 1 by R2 equal to 1 by 4.8. I took LCM. R1 and R2 LCM will be R1 R2. R1 plus R2 is equal to how much? 20. By R1 R2 R1 R2 equal to 20 into 4.8. R1 minus R2 whole square is equal to R1 plus R2 whole square minus 4 R1 R2 20 square minus 4 into 96 equal to 400 minus 16. So copy this down. R1 minus R2 equal to 16 equal to square root of 16 will give you 4. So now we will solve simultaneous equation. R1 plus R2 equal to 20. R1 minus R2 equal to 4. R1 equal to 24 or R1 equal to 24 by 12 equal to 1200. So if you could substitute the value of R1 in any one of these equations, we will get R2 equal to 8 ohm.